Hello and welcome again to our channel, and today we will be discussing building your own exploit. Okay, so the specific exploit that we will do today is the buffer overflow exploitation. Okay, why that? Because most of the exploit in the field is buffer overflow exploitation. So if you know this, then probably you will know how to modify and debug most of the exploit in the wild. Okay, so this is very important. Okay, so first thing that you need is the replica of the OS of your target. Okay, so for example, in here, your target is Windows 7 SP1, then probably you should install an OS that is nearly similar to that operating system. So in here, if you're targeting Windows SP SP1, then probably I will install Windows 7 SP1. So inside the Windows 7 SP1, we will debug the vulnerable software. So of course, we need the vulnerable software. So I will put a vulnerable software in the caption link. And this is not the same software. This is not the same software that we will be tackling today. But of course, I do that in order for you to be challenged. Okay, so grasp all of the techniques in this video, then apply it to the software in the caption. Okay, so in here, this is my software. Okay, so I run it. Then after that, Immunity Debugger, you should install that because in our debugging, that will be used. This is the Immunity Debugger, so that will be used in our debugging. Okay, so after that, after opening this, we should nmap 192.168.1.5. so this is the target SV. Okay, so mostly I already know what is the port, so I'll just show you. The port is 31337. So this is the vulnerable buffer overflow port. So if you don't know what port is the buffer overflow, then probably just connect to it using netcat. So for example, in here 168.1.5, then 31337. Then in here it's asking for an input. So for example, in here Alexis, then enter hello Alexis. So now basically that's the number one. Know how it works. Okay, know how the vulnerable port works. So in here, the software in that vulnerable port is printing the username with hello and 3 exclamation point. Okay, so let's exit here. Okay, so there's also a command that code exit. So that's the first thing we should do, know how it works. Then after that, after knowing how it works, then probably we should create a Python script that will be used throughout this session. Okay, so now we already know how to connect in the port. So we just send a username, then enter it, then probably it will respond. Okay, so let's create a Python script nano connect.py. Then let's import a library that will be used for connection. Then let's initialize the IP address. Okay, I'll just check if it is recording. Okay, it's recording. Our port then the port. Then after that, let's initialize the connection. So socket, 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 that AF, init, socket, that sock, stream. Okay, then S that connect, so that we can connect. So it needs double parentheses. So first the R host, then the R port. Then after that, let's initialize the data that we will send. So of course the username. Then after that, what it needs is a enter command. So this is the enter. Okay, so after that, let's send it. Then after that, let's print what it will send in order for us to be aware, well, what did we send. Okay, then let's initialize this so that we will know what did the target machine receive. Okay, then after that, then let's close the connection. So that's pretty basic. Okay, so I'm encouraging you to learn Python, but just basic. Okay, so but if you want to dig deeper with Python, then it's up to you. So but in here you just need the basic. So let's X and Y, then enter, then Python connect.py. Okay, so it connected. Okay, hello Alexis. So now we already know how to connect. The next one that we should do is to learn how many bytes it will take, or it will receive until it crash or it becomes down. Okay, so that's the essence of buffer overflow exploitation. You're sending a lot of data until it becomes unavailable or it crashes. Okay, so that's the buffer overflow exploitation. So okay, let's fuzz it. So the term that that we will be doing here is called fuzzing. So let's use again the connect.py. So in here, instead of username Alexis, what I will send is a lot of characters. So for example, A times 100. Okay, so X, Y, enter. Then let's run it. Okay, so as you can see here, if you don't have access to the machine, probably in this it ran. Okay, and it didn't crash. And to verify it, let's go here. It's not crashing. Okay, so it means that we should set the data higher. Okay, so from 100, let's go 150, and let's enter this. And as you can see here, it didn't respond to us. So it means that there's a possibility that it crashed. Okay, to verify it, let's go here. Okay, it crashed. Okay, so let's close the program and restart it. Then let's go another here. Okay, so it means that the data that we sent 150 must be lower. Okay, must be lower. So let's send 130. Let's see if it will crash. Enter. No, it didn't crash. So we must set higher than 130 but lower than 150. So 140, I think. Okay. As you can see here, it responds, but there is crashing that happened. So technically, we need to lower it down. Okay, from 140, we need to lower it down. So let's start it. Then let's edit our script. Maybe 135, 139. Let's lower it down. It's still crashing, so it means that much lower. Okay. Okay, so it's still crashing. So let's see. Let's lower it down again. So it's not crashing anymore. So probably the exact bytes that that we are finding here is 138. So in 138 bytes, it will crash. Okay, so that's the information that we want to know. Okay, so we already know how many bytes in order for it to crash. So 138. So let's put here 138. Then after that, what we need to do is to learn or to discover what are okay, so first of all, we need to verify if we are overwriting the EIP. So EIP here is very important. So let's okay, let's go here. Open your immunity debugger, then click file, then attach your buffer overflow software. Okay, then this is the EIP or the instruction pointer. Press F9 to run this then let's go to our terminal, then let's try it. What happened? Okay, I'll just close this. I'll just restart. File, attach. F9. Okay, F9. So after that, it paused. So it didn't crash. So I think, so what are we doing here? So we want to know if we overwrite the EIP, okay, with letter A's. Okay, so in here, I'm not seeing that we overwrite the EIP with letter A's. So it must be 41, 41, 41, 41, 41. So 4 41s. Okay, so I think I need to higher it up. Let's make it 140. Python. And tada! We crush it, but we didn't overwrite the EIP. So let's go for 200. And before that, we need to restart. Okay, we just restarted. Okay, so now Python, and tada! We overwrite the EIP with letter A's. Okay, so that's the goal in here, in the third one, that we already know when it crashed. Then we already know in the third one that when, where, or what bytes it will take in order for us to overwrite the EIP. Okay, so we need to know what specific, or how many bytes in order for us to put in here. So this 41, this 441 here, we need to know what is this, what's in what byte it is. So for example, maybe this is 136, 146, 147, 148, 149 bytes. So we need to know it in order for us to change this, because this will be one of the key turner for this buffer overflow exploitation, in order for us to tell some instruction to this machine. So okay, let's restart it again. So now we can locate this pattern.rb. So okay, pattern underscore create. Okay, so what is pattern create.rb? So the pattern.rb, pattern underscore create.rb, is a Ruby script that we will use in order for us to know what are the specific characters in the EIP that is overwriting the EIP. So the 4 bytes, or the 4, yes, the 4 bytes. Okay, so okay, let's do this. Let's copy this, Control Shift C, Control Shift V, then dash L, then 200. for 200 bytes. So let's enter this. So it will create a unique characters, okay, unique string that we will send to the target. So for example, in this, if we see this in the EIP, then probably the overwriting of EIP happens here. So maybe this is 150 bytes, 151 bytes, 151st, 152nd. So we need to copy this. And then let's comment this out. Then let's create another buffer. Then let's paste it here. Okay, then Control X, Y, enter. Okay, are we ready? Then let's run it. Oops. Okay, line 8. Let's see if we did something wrong. Connect. I think it's reading it. So I think the comment here is, I think, yeah, that's hashtag. So there's nothing wrong in there. Connection refused. Okay, it's not yet running, so let's press F9. Okay, so it's now running. So it's not connecting because our software is down. So we entered. Okay, so it crashed, and as you can see here, this is the one that we need. Okay, so let's write it down. So 3965, then 41, then 38. Okay, so let's copy this, then let's go here. So no, let's go here. So after that, after knowing what are the specific strings in the that overwrites EIP, then we need to know if it is 156, 157 bytes. So we need to know the offset. So that's what you call offset. So let's change this to offset. Then -L200, same. -Q, then the number. Okay, then enter. So it says that the start of overwriting of EIP starts with 146. Okay, so 146, 147, 148, and 149 is overwriting the EIP. Okay, so the next one is, okay, so we already know. We need to fix this. Okay, so we need to do some math here. We just okay, let's calculate. So if we have 200, then minus 146, then there will be just 54. So why did I do that? Then you'll see here. So technically in this you just need 146 for A's. Then after that, let's see if we can overwrite the EIP with B, 4 B's. Okay, so just for us to know that we are now have control with the EIP. Then 50. Okay, so this is in total 200. Okay, then this is the byte before EIP. So technically, correct me, a while ago, the position of the EIP is 147, 148, 149, and 150. Okay, so this is the bytes before EIP, then this is the overwriting of the EIP. Okay, then we just added 50 in order for it to crash definitely. So okay, let's try it. Let's restart this. Then let's run it. F9, F9. Okay, so let's run it. And we hope that we overwrite the EIP with letter B's, which is if A is 41, then B is 42 in hex. Okay, so in here, okay, we successfully overwrite the EIP with 42, 42, 42, 42. Okay, so now we already have the power to overwrite in the EIP. So now what is the next thing that we should do? We should know the bad characters. Okay, so bad characters. So what are the bad characters? So when we send a bad characters in buffer overflow exploitation, then probably it will cut the sending. So for example, if I send 200, just like what I did, then it has bad character, which is for example 42, then which is equivalent to B. Then probably in our 147 bytes, it will start from 0 again. So technically what we send is just 146 bytes. Okay, so yes, it crashes, but you didn't overwrite the EIP. Okay, so that's why this is very important. Knowing the bad character is very important for us to have a flawless buffer overflow exploitation. No rewinding and no like this. Okay, so let's do that, and you can search for the unique characters in hex. So in here I already have this bad chars 1.py. no, okay, so here is my bad characters. I'll just copy this. Then we will put it in our code. So nano because this will ruin our existing code. So I will just connect, then bad.py. So technically, the one that we will edit is the bad.py. So in here, we will overwrite. So bad char equals to okay, don't forget the parentheses here. Then in here, let's put it here, bad char. Okay, so let's exit this. Then let's run this. Okay, let's restart first. Then run. Then run this. Okay. So in order for us to trace our C's or our bad characters, let's go to ESP, click ESP, the ESP, okay, then right click it, then follow in dump. And as you can see here, okay, what is the first bad character that we have? Let's okay, so the first one must be 01. Okay, so it's correct. 02, 03, 04, 05, 06, 7, 8, 9. Oops! It became 21. It must be 0A. So technically, one of the bad characters that we have is X0A. So let's copy this. And let's put it here. Bad char. X0A. Then let's remove this X0A here so that it won't mess with our buffer. Okay, so Control X, Y, enter. Then let's restart this. Then run. Then okay. So again, let's click the ESP, then follow in dump, then let's trace it. So 8, 9, 0B, okay, because we do not have the 0A anymore. 0B, so it's correct. 0C, D, E, F. After the F is 10, okay, correct. 11, 12, 13, 14, 15, 16, 17, 18, 19. What is the next of 19? 1A, so it's correct. A, B, C, D, E, F. After IF is 1F is 20, so it's correct. 21, 22, 23, 24, 25, 26, 27, 28, 29. What is the next with 10 to 9? X2A. So 2A, 2B, 2C, D, E, F. Then 30, 31, 32, 33, 4, 5, 6, 7, 8, 9. Then A, B, C, D, E, F. Then 40, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, E, F. Then 50, 51, 2, 3, 4, 5, 6, 7, 8, 9, 5, A, B, C, D, E, F. 60, 61, 62, 64, 5, 6, 7, 8, 9, A, B, C, D, E, F. Then 70, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Then 8, 2, 3, 4, 5, 6, 7, 8, 9, 8, A, B, C, D, E, F. A, B, C, D, E, F. Then 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, A, B, C, D, E, F. Then A, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Then B, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then B, A, B, B, C, D, E, F. C, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, D, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, E, F. E0, E2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, F, A, B, C, D, E, F. Okay. So technically, our bad character is just X0A and X00. So why X00? X00 is a null byte. Okay, so automatically, every buffer overflow exploitation is allergic with X00. Okay, so most of the time. So let's assume that these two is the bad characters. Okay, so that's pretty hard, but I know you can do it. So let's edit our main and let's put here bad characters is equals to X0A, X00. Okay, so after that, what is the next thing that we should do? We should create a shellcode, I think. But before creating a shellcode, we need to identify the return address because we need to change this into a return address. Okay, so the return address must be okay, let's restart this. So in here we will use mona.py. So we will identify the return address of the vulnerable software inside the system. Okay, so Mona modules. So here's the module, and of course the one that we will choose here is the one that has false rebase, false ASLR, then false safe SEH. Okay, so the false here is this one, this line, which is our buffer flow.exe. Okay, so after that, let's identify the return address of that buffer overflow.exe. So in order to do it, exclamation mona, then find, then s, then slash ff slash e4. So for the one that is asking what is xff, then xe4, that's the jump and esp. So we need to go there in order for us to fully control the machine. Then -m, the name of the software, which is for us buffer overflow.exe. Then let's enter, and tada! Here's the return address that I'm talking about. Okay, so we should choose a return address that doesn't have a bad character. And fortunately, this two doesn't have bad character. So we can use this. We can use the first one, which is 08, 04, 14, then C3. Okay, but let's view the system info of this. Okay, so in here we will, when we write it down, okay, so let's copy this, Ctrl Shift C, then let's edit our, so return address is equals to this. Okay, then after that we need to reverse it. So from 08, the first one will be 6C3. Okay, so XC3, then X14, then X04, then X08. Okay, so this will be the main value of our return address in here. So technically, this is 4 bytes. 1 byte, 2nd byte, 3rd byte, 4th byte. Okay, so here. Okay, so definitely this is it. Then okay, so let's create now a shell code. Okay, so in order for us to create a shell code, then msf venom -p windows shell underscore reverse underscore tcp, then your IP address, because in our shell code it will find its master. The master is us. So wait, what is my IP address? So I'm .6. Then L port equals to, it must be an unused port. So 1, 2, 3, 4. Then after that -b, what is the bad character? So this is the use of our exploration a while ago of bad characters. So it will produce a shellcode that doesn't have these characters. Then after that, -f, then it must be, I think, in a format of C. So the character that it will create is in the format of C, but not technically a C code. Okay, so just the variable. Okay, so C. Okay, I think that's enough. Okay, so let's do this. Okay, so after that, let's copy this without the semicolon. Okay, because in Python there's no semicolon. So copy the characters, then go to our connect.py, then initialize this shellcode, parentheses, paste. Okay, so here's the shellcode. Then where will we put in that shellcode? Then we will put it here. However, Okay, guys. This much. This is slightly complicated. So there is NOPs. Okay, so NOPs is just a filler. Okay, so just a filler, or there's no operations. That's why it's NOPs. No operations. So in here, we will guess what is the best place of our shellcode in the system. So mostly it is 8 NOPs before putting our shellcode, or 16 NOPs before putting our shellcode, or 30 NOPs, 32 NOPs. So it's in a variable of 8, but most probably it's like that. So in here we will guess that it is 16 in 16. So okay, let's do that. So the value of our NOPs is x90. Okay, then asterisk 16, because we want to put our shellcode after 16 NOPs in order for it to give us a shell. Okay, so exit y, then enter. Then let's have a listener, nc-nvlp. Okay, let's divide this. Let's have a listener here, 1 2 3 4. Then let's restart this first and run this. Python connect.py, then enter, and tada! We already have a shell to the terminal, to the Windows, to the target that we have. So yeah, pretty much it. So we are already done with the buffer overflow exploitation and the building of your own exploits. So technically that's the principle. Know how it works, okay? Then know how to connect with the software, and technically it must the better is you install the same OS in order for you to debug the software, and to dig more about the software and know the bad characters of that software and know the return address of that software mostly. So that's the most important thing to do. Then after that, creating the shellcode, then getting a shell. Okay, so that's it for today, and I hope you learned something. So it's a pretty long lesson.